Okay, today we jump back into chapter 15 real briefly, one section, section 15.2. We're going to talk about complex numbers. Remember where we're headed. We want to be able to solve quadratic equations. And we're going to see that complex numbers play a big part in solving quadratic equations. So, Friday, we will actually begin to talk about how to solve quadratic equations that don't factor. So that's where our goal is. That's our goal for now. But before we can do that, we have to talk about complex numbers. So complex numbers. A long time ago, somebody wanted to solve that equation, x squared equals -1. Well, you have a problem if you try to solve that equation. What's the problem? If I plug a number in, like 2, and I square 2, what kind of answer do I get? Positive, I get 4. What if I plug a negative number in? If I take a negative number and I plug it in and I square it, I get a positive again. So a lot of people will tell me the answer is -1, but -1 is not the right answer. Why not? -1 times -1 is +1. And 0 is not the right answer. So what's the problem with this equation? There's no answer, is there? There is no real number solution to this equation. Well, what do you do if there's no real number solution? You make up an imaginary one. Just like when you were little and you didn't have any real friends, what'd you do? You made up an imaginary one. Same sort of deal. So, we define I to be equal to the square root of -1. And call this an imaginary number. Imaginary number. Well, that leads us to some things then. We can now write a symbol for the square root of -4. The other day when we talked about square roots, we would have said this is not a real number. But now what we're going to do is we're going to say, well, the square root of -4, that's the same as square root of 4 times -1. And what's the square root of 4? 2. And the square root of -1? I. So we're going to say the square root of -4 is 2i. Questions on that? Okay. How about the square root of -50? What would you do to simplify the square root of -50? I'm going to take 50 and write it as 25 times 2, and then I still have the -1, don't I, to get -50. So it's the same sort of deal we did the other day. We take the number 50, we factor it as 25 times 2, because the square root of 25 is a nice number, and then we've got this -1. What's going to happen with that -1? That's going to be an I. So what would you write for your final answer? All right, 5 square root of 2i. Now you need to be careful. When I learned algebra, if I wrote that answer, my teacher would have marked it wrong. Yeah, my teacher was very, very fussy. My teacher would say, it's not clear if that I is underneath the square root or not. Should the I be underneath the square root? No. All right, so my teacher had two solutions. Option number 1 was we could do that to indicate that that's where the square root ends. Or even better, the way we typically write these we put the square root at the end. And then there's absolutely no doubt in anybody's mind if the I is underneath the square root or not. So typically that would be written as 5I square root of 2. Is it wrong to write it as 5 square root of 2I? No, it's not wrong. It's just, it's not as clear, it's not as obvious. Questions on that? Yes?
So the negative 1 always come out of that?
The square root of negative 1 is always going to come out to give you an I. Absolutely. Yep, so if you see square root of negative, I don't know, give me a number that you like. 16. Square root of negative 16. Right away you see you have a negative underneath your square root, you know your answer is going to have an I in it. The only question is, can you do better? Can you simplify square root of 16 at all? Yeah, that turns out to be a real nice number. So the answer is 4I. Square root of 16 is 4. Because we have the negative, we get the I. All right. A complex number is any number that can be written in the form A plus BI, where A and B are real numbers. Examples. 2 plus the square root of negative 9. Is 2 plus the square root of negative 9 a complex number? Yes, because A and B are real. A is 2. What's B? Not negative 9.
1.
Not 1.
Yeah.
3. B would be just a number 3. Because you could write this as 2 plus, how do you simplify the square root of negative 9? That's 3I. So A is the number 2, B is the number 3, and then we have the I. So A plus BI. So that is a complex number that can be written in that form. How about 6 minus the square root of negative 36? Is that a complex number? No, why not? It's a minus, okay. But couldn't I do this? I could write this as 6 minus 6I. And then if I really wanted to, couldn't I write that with a plus in the middle? Couldn't I write it as 6 plus negative 6I? So is that a complex number? Yes, in this case A is the number 6 and B is the number negative 6. 7. Is 7 a complex number? No, why not? There's no B? You sure? There's no I? You sure? Could I write 7 as 7 plus 0I? Are those the same? Yes. So is 7 a complex number? Yes, it is. More importantly, 7 is a real number, but it turns out that 7 is also a complex number. I can write 7 as A plus BI. Nowhere in my rules did it say that B couldn't be the number 0. And B can be the number 0. That's allowed. So all the real numbers are also complex numbers. It's more important that they're real numbers, but they are also complex numbers. And I could do the same thing with something like the square root of I don't know what nice number haven't I used yet. Square root of negative 25. Square root of negative 25 is 5i. Can I write it in the form a plus bi? Yeah, where a is the number 0. So I could write it as 0 plus 5i. It turns out that all numbers, every number you can ever think of in the whole universe, is a complex number. All numbers are complex numbers. Like I said, it's more important that some numbers are real, such as 7, but everything is a complex number. All right, what we're going to do today is operations with complex numbers. In other words, we're going to talk about adding, subtracting, multiplying, and dividing. Add and subtract. How would you take 6 plus the square root of negative 100 and add that to 4 plus 2 square root of negative 9. What do you think you do to add two complex numbers? Break them down first. All right, so by break them down, I think you mean you're going to write this one as 6 plus 10i. And then the second one is 4 plus... We get 3i, but it already had a 2 in front of it. 6i, because that's multiply there, right? So the square root of negative 9 gives us a 3i. But then we're multiplying that by 2, so that's going to be a 6i right there. So I agree with you. We get rid of the square roots first, we break them down, and then how do you add? Combine like terms. The fact that you have an I here is no big deal. You add them just like you would if they had x's in them. 10 plus 16i. So once you get them written with the i's, it's very easy to add them. You add them just like you do any old expressions. How is subtraction different? 4 minus the square root of negative 49 minus 2 minus the square root of negative 81. How is subtracting any different than adding? It really isn't. You got to be careful of one thing, though. It's the one thing you got to be careful of. You're subtracting. Watch out for your minus signs. People make mistakes with minuses. That's all really. So we're going to write this as 4 minus 7i. And then we have to distribute this minus sign through. So that's minus 2 plus 9i. And that's the big mistake people make. They forget to distribute that minus sign through and turn that one into a plus right there. Final answer? 2 plus 2i. All right, so add, subtract. That's pretty easy. Multiply. How do you multiply two complex numbers? How do I take 3 plus 4i and multiply it by 2 minus i? Not factor. FOIL. Just like you would if these were x's. If this was 3 plus 4x and 2 minus x, you would tell me do FOIL. That's exactly what I'm going to do. I'm going to do FOIL. When I do FOIL, I get 6 minus 3i plus 8i minus 4i squared. Then what do you do? Add, combine your like terms. What do you get when you combine like terms? 6 plus 5i minus 4i squared. Now, we're not quite done, because that's not written as a complex number. a complex number is supposed to have a plus bi. It's not supposed to have an I squared in it. So we have to do something with that I squared. Any ideas?
Break down 4i squared.
And how do you break down 4i squared?
I squared is -1.
I squared is negative. Why is I squared -1?
Calculator.
Calculator said so. All right, and we trust our calculator. What did we say I was again? What did we define I as? Not any number. Not -1. Square root of -1. So what happens if I square that? Well, what does a square do to a square root? It cancels it out. You get -1. So we're going to come back here and we're going to write this as 6 plus 5i plus 4. That I squared is a fancy way of saying -1, and two negatives make a positive. So that one turns out to be a 4. And now we can combine like terms again. That's 10 plus 5i. Questions on that one? Bless you. Okay, so multiplying isn't that big a deal. To multiply, we do FOIL. So if I have 5 minus 2i, and I want to multiply by 3 minus 8i, I do FOIL just like I've always done. I like FOIL. I'm good at it. You guys like FOIL. You're good at it. That's 15. Minus 40i. Minus 6i. Plus 16i squared. You're going to combine your like terms. You're going to write 15 minus 40i minus 6i is minus 46i. And then what are you going to do with that plus 16i squared? You're going to write it as negative 16. I squared is the number -1. The I squared goes away, becomes a -1. And then combine your like terms again. Final answer, -1 minus 46i. Questions on that? All right. Dividing. Dividing's not too bad. If I have 3 plus 2i over 4 minus I. What we do to divide is we multiply the top and the bottom by something special. And here's what you do. You look at the bottom. The bottom is 4 minus I. We're going to multiply by 4 plus I. Whatever you have on bottom, you take the exact same thing except you change the sign in the middle. If it's a 4 plus I, if it's a 4 minus I here, we write a 4 plus I. There's a name for that. Anybody know the name for that? Anybody know the name for change the sign in the middle? Conjugate. Excellent. That's called the conjugate. Is it important to know the name? No, not really. It's important to know what to do. We change the sign in the middle. Why? Go ahead, Junior.
Well, I want to go back to the multiply.
Uh-huh.
When I said that the subtraction in the middle wasn't like the right way to write it.
No, it's okay to write it as subtraction in the middle. I mean, if you want to be really, really pedantic, you could write it that way. If you really, really want it in A plus BI form.
So is that okay to write like a subtraction?
Yeah, typically we leave it just like that. We're not usually that fussy and write it that way. Okay, so back to dividing. We multiply top and bottom by the conjugate. Why the conjugate? It doesn't cancel out the bottom, but it comes close. Let's do the bottom first. What happens when you multiply these? Well, you do FOIL. 4 times 4 is 16. And then on the outside, plus 4i. Inside, minus 4i. And on the end, minus I squared. So what happens? You get rid of the i's because the 4i and the minus 4i, those add up to 0. And the I squared is -1. So down on bottom, we have 16 plus 1. So that's the idea behind the conjugate. The conjugate, when you multiply by the conjugate, it's going to get rid of the i's down on the bottom. And that's something you should recognize. What did we use there? Something we've talked about before. What happens when you have a plus b and you multiply by a minus b? That's basically what we did. We changed the sign in the middle. What happens? What do you get? This is one of our factoring formulas. You get the difference of perfect squares, a squared minus b squared. So that's why we use the conjugate. We're using that formula. That formula makes the middle two pieces go away. Well, now we're going to do FOIL up on top and see what we get. Up on top we get 12 plus 3i plus 8i plus 2i squared. That becomes 10 plus 11i. How did I get 10? That last one turns into a minus 2 because I squared is a fancy way of writing -1. So I have 12 and -2, that gave me 10. And then I added my like terms, that gave me 11. All right, so we could write this as 10 plus 11i over 17. And that's a correct answer. However, when you go online to do your homework on MyLab is very fussy about this. It's not fussy about the minus signs up there. On MyLab, it requires you to write it this way: 10 over 17 plus 11 over 17i. Why do you think it does that? Go ahead.
You have the a plus b.
So you have the a plus bi, correct? So a is 10 over 17, b is 11 over 17. So MyLab can be very fussy about that. So if you type this in and it marks it wrong, it's not that you did it wrong, it's that you didn't write it in the answer that it wants. So watch out for that. You got to write it as a plus bi. If it's a minus in between, MyLab is okay with that. You can have the minus in between, but it doesn't like the fractions. All right, one more divide, and then we'll talk about some exponents. How about, I don't know, make up some numbers for me. 6. Somebody give me another number.
Plus 3i.
Plus 3i. Divided by. 8. Need one more number.
4.
Minus 4i. This time, what am I going to multiply by? What's my conjugate?
8 plus 4i.
8 plus 4i. Whatever you have on bottom, you simply change the sign. We do FOIL. 6 times 8. 48. Plus 24i. Plus 24i again. Plus 12i squared. Down on bottom, 8 times 8 is 64 minus 16i squared. Notice I didn't even bother with the middle two terms. How come I didn't bother with the middle two terms? They're going to cancel out. I don't even need to bother with them. I know they're going to cancel out. Alright, just got to simplify now. This is a 48. This 12i squared becomes a negative 12. 48 minus 12 is 36. Plus 48i divided by 80. Because again, I squared is negative 1, so that's going to be 64 plus 16. So that's 80. And again, as far as I'm concerned, that's a perfectly acceptable answer. My lab's not going to like it. My lab's going to say you better do 36 over 80 plus 48 over 80i. And even that it probably wouldn't like. Why not? I can simplify both my fractions, that's correct. So what can I reduce with a 36 over 80? I can reduce by 4, I think. 36 divided by 4 is 9. 80 divided by 4 is 20. Plus, how about 48 over 80? 8. That's 48 divided by 8. 6. And then 80 divided by 8 would be 10, so that would be 6 over 10. But 6 over 10 reduces more to 3 over 5i. I think that's the answer my lab would force you to put in. It would want all your fractions reduced. Questions on that? All right, the last thing we have to talk about is powers. What's I to the 0? Not 0. What's anything to the 0 power? 1, except for the number 0. I to the 0 is 1. I to the 1, that of course is just I. I squared we already talked about. I squared is negative 1. How about I cubed? Negative I. How'd you get negative I? Calculator. Oh, your calculator is very smart. How about we take I cubed and we write it as I squared times I? And then I squared was the number negative 1, so that turns out to be negative I. How about I to the 4th? 1. Because the calculator said so? Yeah. All right, I got a better answer. I to the 4th, I could do a similar trick as what I did for I cubed. I to the 4th is I squared times I squared. What's I squared? What's negative 1 times negative 1? Positive 1. I to the 5th? 1i, because that's I to the 4th times I. And I to the 4th we just figured out was 1, so that's I. I to the 6th? Not I. Negative 1. Why negative 1?
It would be negative I 5 times I.
It would be I to the 5th times I, which is I times I, which is negative 1. Or here's what I was looking at. I noticed it meant 1i, negative 1, negative I. 1i, negative 1, negative I. The next answer is I to the 7th is negative I. It seems to go in a pattern and cycle. 1i, negative 1, negative I. 1i, negative 1, negative I. I could keep going, couldn't I? Is it ever going to change? No, I'm going to get those 4 things. All right, so how much is I to the 1,967? Well, it's one of those 4 things. You have a 1 in 4 chance of being right. Any guesses? Negative I. How'd you get negative I? You just guessed. I think that's the right answer.
I just thought because it ends in 7.
Because it ends in a 7? Well, so really you can narrow it down to a 50-50. Because notice the odd powers, 1, 3, 5, 7, they'll have an I or a negative I. And the even powers are all 1 and negative 1. So you really have a 50-50 chance of being right. But here's what you're going to do. You're going to take 1,967 and you're going to divide it by 4. Why divide it by 4? Because there's 4 things in the pattern. All right, so let's see, that's 4, 16, 36. That's a 9. Bring down the 7. So that's 491 remainder 3. What this tells me is, if I were to keep listing I to the 8, I to the 9, I to the 10, so on and so forth, to get down to I to the 1,967, I would go through the pattern 491 times. And I'd be right here. And then I'd have to go 3 more steps. So you do this division, you take the 1967, you divide it by 4, and it's always I to whatever your remainder is. This 491 tells you how many times you cycle through the pattern, and then you have 3 steps to go. I cubed is negative I. Questions on that? All right, well, I heard somebody keep saying, I use my calculator. How do you use your calculator?